Okay, let's look at this one. Here is a bearing question. Question number one. A helicopter flies from its base B to deliver supplies to two oil rigs C and D. C is 6 kilometers due east. Okay, so this is one of the information that you can use to identify the bearing. So C is due east of B, so you can actually say that this is 90 degrees already. Because north, south, east, west is just 4 right angles combined together. Okay, so once this is sorted, and the distance from C to D is 8 kilometers, D is the bearing 120 degrees from B. So whenever we do bearing questions, every single north, they are considered to be parallel lines. Like for example, this is parallel to this. And if I draw a north line here, this is parallel to this as well, or this is also parallel to this. Okay, I can extend the line like that, and then they'll be parallel lines. So you say find the bearing of D from C. So first you need to identify where you're looking from. So the key here is that you're at C. So this is where you are. You need to find D from C. So this is 90 degrees. This is also 90 degrees. Can we find any other angle? So this is 30 degrees. Well, this is 60 degrees. Okay, 60 degrees is from a parallel line here, 180 minus 120. These two parallel lines. Okay, and just identify all the angles that I can before I start. Okay. Well, the angle that we're looking for is this. So my game plan is actually to find this one here and take 180 minus this, because these two lines are parallel. So it means that this and this adds up to 180. So first I need to find out what this is. Okay, in order to find out what this is, I need to find out what this is. So I'm going to use my sine rule. So using sine rule, to find angle CD. So sine angle CDB over, so opposite will be this one. 6 is equal to sine 30, 8 kilometers. I should be able to find it. I'm just going to get sine 30 divided by 8, multiplied by 6, inverse sine, my answer, and I should get 2.02431284 degrees. So how do I get 0.375? Basically, this is sine 30 divided by 8 multiplied by 6. That's how I get. This is just rearranging the formula. Right, then I get this angle here is 22. So the remaining angle here that we're looking for will be 60 minus 22.02431284. 37.97568716. So this is the angle there, and then I just need to minus. So I'm just going to write it here. So this represents here. Now I just need to find out the last one, bearing of D from C. 180 minus 37.97568716. 142.02431 each. This one, I can just put 142. Now, let's go to the next question. AOC is a diameter of a circle. So each and every word here, each and every statement that we get here, we need to find out what it means. Whenever you have a diameter, we need to see if there's any angle formed by this diameter. Well, none. If there is, it means that it's 90 degrees. But there isn't, so we're just gonna put it there as it is. AT is a straight line that cuts the circle at B. Okay, straight line. PT is a tangent to the circle at C, so I can just tangent means it's 90 degrees. Angle COB is 76. Okay, so since AOC is a diameter, which means it's a straight line, I can find AOB. So let's see what they want us to find here. Calculate angle ATC. Yeah. So what we're going to do is we're going to use this triangle. Okay, triangle ATC to find it. So first of all, we have one angle already. We need to find this one here. So now I need to find angle OAB, which is equal to 180 minus angle AOB divided by 2. Why divided by 2? You say it because it's a isosceles triangle. Isosceles triangle here. Because they are the sides of this triangle are 2 radii. You see, this is a radius, this is a radius, so they have the same length. So I can say that. So I don't have angle AOB, so I just need to find angle AOB. 180 minus 76. 104. So 180 minus 104, which is 76 divided by 2, which is equals to 48. Okay, not 48, 30. So after that, I can just say that angle ATC is equal to 180 minus 90 minus 38. 50. Yes, that is correct. T is due north of C. Calculate bearing B from C. B from C. We need to calculate this bearing. So we have from C. So let me just erase everything here for a moment. And then we're from C. So this is where we are. And then this is our north. B from C, it means that I need to calculate this angle, right? Okay, all we need to do is find angle BCO. Okay, we need to find this angle here. Why? Because when you just take this angle and add by 270. So I'm just going to find angle BCO. It is also an isosceles triangle, mind you. Because it is also drawn by two radius as a side, 2 radii. So 180 minus 76 divided by 2. 52 degrees. Okay. Then bearing from C is equal to 270 plus 52. 2, 2. Okay, for bearing question, you just should be able to see. Okay, you need to identify what you need to look for and then slowly try to figure that out. So let's look at question 3. A plane flies from Auckland to Gisborne on a bearing of 115 degrees. The plane then flies to Wellington W, angle AGW 63 degrees. Okay, everything is drawn for you. Calculate the bearing of Wellington from Gisborne. W from, where we from here. Going to find this out. Yeah, this is the one that we're looking for. Okay, how do we do that? We take 360 minus 63 minus this. All right, so that should do. So let's just take that first. 360 degrees minus 63 minus, how to get the question mark here? We're going to take 180 minus 115. I'm just going to put it inside 180. Because it's rather difficult to actually identify which angle we're looking for. It's very difficult to communicate that way. So I might as well just write the working in, and then we should be able to see the results. $232 is the answer. The distance from Wellington to Gisborne is 400 kilometers. Yes, those are written. Calculate the bearing of Wellington from Auckland. Wellington from Auckland. This is, oh, sorry, this is where we are. X marks the spot. So the angle that we're looking for is 115 inclusive of this angle right here. So we can actually use the sine rule to find that. So I can just say GAW. So we're looking for angle GAW over, well, opposite will be 400. It's equals to 63. Opposite is 400. This is your sine rule. So you can get your answer. Sine GAW is equal to sine 63 divided by 410 multiplied by 4. Zero point 86927465 angle GAW. Inverse sine it. 60.3744515 degrees. So bearing is equals to 115 plus that. $75.3. Yes. Let's look at the last one here from Harbour Heath. The ship of a bearing S is 312. The ship is 3.5 kilometers from the harbor. So sketch of the information, label H as the length 2.5 and the angle 312. Whenever the question asks you to sketch, it means that you do not need to follow any form of scale. All you need to do is you need to have a rough estimate of where things are. All right, so you cannot just say like, oh, I'm just going to draw this. Oh, this is absolutely wrong. You cannot, because concept-wise, 312 is not that big. It's not that small, sorry. 312 is way bigger. So normally you need to rely on your quadrant. So here's 90, here's 180, 270, 360. So this is your one full circle. So this should be somewhere around here. So let me just draw here. Harbor bearing of a ship is 312. Okay, so now from harbor, this is your harbor, 312 here. And that's it. HS, yeah, then harbor the ship. Okay, how far north? Okay, how far north? This type of question means how far is it? If I'm comparing, this is my north. Where is this? How far north means this height here? Okay, so if you imagine it, we're in a coordinate grid. Basically, they want to find the difference between these two. So they just want how far north. If I want to be on the same position with it on the north, how far must I go from the harbor just to see it side to side, to be on side to side level with it? So I'm just gonna extend so that I can draw out a triangle, because that helps me to identify what I have and what I don't have. So here, once I draw it out, I should be able to see it should be a 90-degree because we're side by side, right? And then we should be able to get an angle here. Okay, so this angle here will be 360 minus 312. So I'm just going to write it down here. 360 minus 312, 48 degrees. Okay, so that is 48 degrees. So with that in mind, you can actually find out here, because this is what I'm looking for. So I have a right angle triangle that looks like this. So I'm just going to sketch my right angle triangle out so that we can have a closer look at it. And I'm looking for this line right here. So I can use one of my trigonometry ratio opposite, or I can just write it out, Tuakaso. Tuakaso. So what can I use? I have hypotenuse, and I need to find my adjacent. So I'm going to use cosine. Cosine 48 adjacent over hypotenuse. Adjacent is equal to and then you should be able to get your answer. Kilometers. And that's it.